In this lesson, we are going to learn one of the most important concepts in science, and that is called conversion factors. And how do we use conversion factors in measurement and chemical analysis in chemistry? Well, we know that in a chemical measurement or any measurement in chemistry has three parts. And the parts multiply each other. They're not adding to each other, but they are multiplying each other. And I'm going to explain that later. Well, the first part is a number. And that number times, I'm referring to multiply, okay? A standardized unit of measurement. And that, again, times, within this case, is going to be multiply. Again, I'm talking about multiplication. So the three parts multiply each other, and the last part is a chemical, more specifically a chemical formula. For example, we have H2O, that's a chemical formula. Now to simplify this, we would have a number multiply a unit times a chemical. For example, let's look at this one. Let's say we have 100.00 milliliter of H2O, which is water. See this right here? That would be your number, this would be the unit, and this right here would be your chemical. So that is a chemical measurement, or any measurement in chemistry. Now, how is that important? Well, we are now going to jump into something called conversion factor. Think of the term conversion. Well, when you convert one thing to another, you are changing, okay? So think of conversion, think of change. But one of the beautiful things about conversion factor, even though you change the look, in this case, you're changing the unit of measurement, the values does not change. Now, by definition, a conversion factor is a ratio of two equivalent. Now, that's a lot of terms that we have to remember. Well, a ratio can be expressed with an equal sign, right? Or it could be expressed as a fraction. Those are ratios. Now, of two equivalent, what is equivalent? Equivalent, thing of the word equal right here, which is represented by the equal sign, or in math, we represent by a fraction, okay? Or just like that. Now, in this case, equivalence of what? Well, equivalent measurement. Two measurement of completely different units, but they have the same values. That is considered a conversion factor. A fraction, which is something that you see all the time in your math class, is a common form of ratio. For example, in this case, we have $1 is equivalent to 100 penny. And notice how we use a singular form just to make the math more simplistic. Or we have 1 meter equal to 100 centimeter. Or we can have 1,000 gram equal to 1 kilogram. Notice how these are all expressed in terms of fraction. And then we have 12 inches equal to 1 foot. Now, because it is a fraction, we can now rewrite this in terms of 100 penny over $1. Or over here, we can do the same thing, 100 centimeter equal to 1 meter. Or here we can do the same thing, 1 kilograms. Then we have 1,000 grams. And we have 1 foot and 12 inches. And that's the beauty of expressing a ratio as a fraction. Now we can multiply this conversion factor to change from one unit to another unit. In this case, between penny and dollar, centimeters and meter, kilogram, gram, foot and inches.
In this lesson, we are going to use the SI prefixes and Mighty King Henry mnemonic device to write conversion factor between two units. Here I have the Mighty King Henry. I only wrote the first letters. Now let's go back and figure out the value of the prefixes for each of the letters. We are going to start with the base because base is the easiest one to memorize because 10 to the 0. Going this way towards mega, the exponents increase by 1. Going towards the pico, the exponents decrease by 1. One way to memorize going towards mega, the exponents increase is look at the mega, it's capitalized, but pico is not. So we're going to start with the exponent that going towards mega. So this one is 10 to the 1, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Keep in mind all these numbers are exponents with the base of 10. So 10 to the power, on the computer program, you will represent 10 as a capital E, and then you will have your number. However, on the calculator button, it will always be EXP or EE. And this one will be the computer. So we're going to learn how to write a conversion factor for centigram and gram. Let's look at centi. 1 centigram equal to, let's look at centi, 10 to the -2. So 10 to the -2 gram. But on the computer, we will have to input it as the 10 to the -2 will be capital E, -2 gram. So C and 10 to the -2 centi is equal to 10 to the -2. Now, numerator is on top, denominator is on the bottom. We are going to learn how to submit our answer. Write your conversion factor with a numerator as measurements with a base unit. Alright, our numerator that have a base unit. So which one is my base unit? Gram. So therefore, capital E, -2, power, and gram. Denominator will just be my 1 centigram. And let's write it into fractions so that you have an idea how it looked like. So my numerator, like I say, it will be E, -2 gram, divide by the denominator is 1 centigram. And this is how it looked like when you are writing it into fraction. However, this is how you will submit your answer, but you need to understand how to write it into a fraction before submitting your answer. Now we're going to learn how to rewrite the conversion factor above with the numerator as a measurement with a unit with a prefixes. The first one, numerator, it with a base unit, but now a numerator with a prefixes. So same thing, we have our numerator divided by our denominator, and which is, but here your numerator had to be prefixes. Keep that in mind. So it's going to be 1 centigram divided by the denominator, E to the 10 power of -2. Now let's submit our answer. So your numerator is 1 centigram. Your denominator will be capital E, -2 gram. Okay. Now you should see a pattern, okay? A centi will always be a 10 to the -2. So this is your prefixes right here. We always have to put a 1 in front of our prefixes. And now let's go back and look at our letter C. letter C on the Mighty King Henry is 10 to the negative 2. So 1 centigram equal to 10 to the negative 2 gram. Now let's put it into fractions. So for this one, 10 negative 2 gram divided by 1 centigram equals to, this one I put it into fractions, numerator divided by the denominator. The numerator is 10 to the negative 2 gram divided by 1 centigram. But look at here, they flipped. And they can flip because the numerator and divided by the denominator, they all have the same value. Second problems, okay? It asks you to write your conversion factor with a numerator as a measurement with a base unit. So my numerator is going to be my base unit. So liter is going to be my base unit. Okay, so I'm going to start with 1 milliliter. Okay, so I had to go back to on the Mighty King Henry. So the letter M have a 10 to the negative 3. 10 to the negative 3 liter. But however, when we input it into our computer, the 10 would represent capital E to the negative 3 liter. Okay, now let's put it in our fractions. Now my numerator must have a base unit. So which one have a base unit? And my base unit is letter L. Look for the only one with the letter L. So this will be my numerator. My denominator is gonna be 1 milliliter. Now let's submit our answer. Numerator, capital E. Okay. Denominator is 1 milliliter. Okay. Now let's move on to rewrite the conversion factor above with a numerator as a measurement with a unit with a prefix. So first thing you do, you have your numerator divided by your denominator. Okay. And this time my prefixes. So I'm going to look for prefix, something with milliliter, because M is my prefix. So therefore, it's going to be 1 milliliter divided by my denominator. This time my denominator had to be a base, so which is liter. So it's going to be capital E, negative 3 liter. Submit our answer in the box. Numerator, 1 milliliter. Denominator, capital E, negative 3 liter. So remember that 1 is the value always in front of a prefixes. So 1 milliliter, and look for milliliter on the Mighty King Henry, which is 10 to the negative 3. So that 10 to the negative 3 for the liter. And here I put them into fractions, but you notice that they can flip. It's because they still have the same values.